Hello students. Now we are going to discuss about the reactions of amines. The very first reaction, that is reaction of nitrous acids. Let's start with the first reaction. So now reactions of amine and the reaction of nitrous acid, that is HNO2. The very first point we need to know over here is that HNO2 is prepared by a reaction between NaNO2 and HCl, which gives HNO2 and NaCl. So now let's start with our reaction. Nitrous acid reacts differently with primary, with secondary and with tertiary amines, and if this is true, obviously it can be used as a distinguishing test between primary, secondary and tertiary amines. Now what we need to know over here is the reaction with primary amines. It can be in two ways. Either your primary amine is aliphatic or it is aromatic. Let's start with the first, that is aliphatic compounds or aliphatic amines. Here, in this case, we take an aliphatic amine, that is RNH2, treat it with NaNO2 and HCl. We get firstly a compound, that is HNO2. Now what happens? For this, there is an interesting shortcut. Let's recollect this. Now, we have NH2 added to HNO2, which can be written as OHN double bond O. Fine. Now what we are doing is, we are breaking the bonds. Onto the extreme left hand side, are you having ROH? Yes, so it becomes your first product. Next, in the middle, are you having two nitrogen atoms? That means N2, it becomes your next product. And finally, are you having H2O? Yes, so that becomes our last product. So what is the entire reaction? It is primary amines treated with HNO2 gives ROH, that is alcohol, water and nitrogen gas is liberated. Now, what we need to know over here is that this reaction actually takes place in a two-step process. Let's understand that. Firstly, an amine, that is primary amine or aliphatic primary amine, reacts with HNO2, gives us a diazonium salt or a diazonium halide salt. When this diazonium salt reacts further with water, it gives alcohol, HCl and N2 gas, which is liberated. But in exam we need not write this. So what is the net result of the reaction is, both the diazonium groups gets cancelled out, HCl gets cancelled out, and the net reaction which we are remaining is the reaction in your orange box. Further, let's now understand with the help of an example. We take ethylamine, treat it with NaNO2 and HCl, that is HNO2. Now what would happen? We get ethyl alcohol. Along with this, we get water and nitrogen. Further, let's now understand what if benzene diazonium salts were treated with HNO2. For this, we need to prepare them. So let's take phenylamine, that is alanine. Now what would happen if we treat this with NaNO2 and HCl? That is, again, NaNO2 plus HCl gives HNO2 and NaCl. So we are treating actually with HNO2, and in the presence of some excess amount of HCl, what do we get? Let's check out. We get the first compound, that is water. Now OH, or rather one H2 is already formed. We get formation of one more H2O molecule. So that means how many H2O in all do we have? We have two H2O molecules, and therefore right now we can say yes, one of the byproduct is 2H2O. We have already used all the compounds or all the groups in green boxes. So what we are remaining is with benzene attached to nitrogen, a next nitrogen atom and a Cl. All of them combined together giving us a compound, that is benzene diazonium chloride, which is a diazonium salt. Now, in this case, we need to know that what we have introduced is nothing but a diazo group into an aromatic ring, and therefore this entire reaction is called as a diazotization reaction. Now students, there comes a very important point in this entire discussion. The point says that aliphatic amines with nitrous acid gives a corresponding alcohol and liberates nitrogen because their diazonium salts are less stable, while aromatic amines gives diazonium salt which are comparatively more stable. Thus, the reaction happened to stop at a diazonium level, whereas in the previous case it went up till alcohol level. So that's all for this module, students. Meet you in the next module. Till then, thank you.